I gave two of the cheapest coding models access to an empty folder and one completely unreasonable task: build Minecraft, Counter-Strike, and Vampire Survivors from scratch. No starter code, no manual fixes, and no stopping until the games were ready to run. One model created a surprisingly good voxel engine. One invented tactical enemies whose main strategy was standing completely still, and somehow, both of them created a genuinely playable Vampire Survivors clone. First, I needed a challenge that was difficult enough to expose the differences between the models. A simple landing page would be useless. Almost every modern model can produce one. So I searched through benchmark tools, prompt libraries, coding communities, and model arenas. One suggestion kept appearing: ask the model to build a complete interactive game that tests architecture, mathematics, state management, performance, debugging, and whether the model can actually finish a large project. I used ChatGPT to turn that idea into an absurdly detailed specification. The first prompt was almost 400 lines long. It asked for a playable Minecraft-style game using TypeScript, Vite, and Three.js, complete with procedural terrain, chunks, collisions, block placement, destruction, and local saving. Then I pasted the entire thing into the agent. DeepSeek immediately divided the project into smaller phases. It created the Vite project, installed Three.js, designed the world structure, and began implementing procedural terrain. Then it built a chunk system, player movement, collisions, and block interactions. For the next 26 minutes, it created files, encountered errors, modified its own code, and continued without asking me a single question. Eventually, it declared the project complete, which, as I was about to learn, does not always mean very much. But this time, the completion report was surprisingly accurate. DeepSeek had created 16 source files across 7 directories, and when I opened the game, it actually worked. The world had procedural mountains, beaches, water, trees, and new chunks loading as I moved around. It maintained roughly 60 frames per second, displayed the player coordinates, and included a functional hotbar. More importantly, I could place and destroy blocks. The visuals were basic, and the water looked more like transparent blue plastic, but this was undeniably a playable voxel sandbox. From an empty folder to a working Minecraft-style prototype in about 26 minutes. DeepSeek had set a much higher bar than I expected. Now, I saved the DeepSeek project, created a fresh directory, switched to MiMo v2.5, and gave it the exact same prompt. MiMo completed the project slightly faster, in approximately 23 minutes. Its report claimed that it had implemented procedural terrain, optimized chunks, first-person controls, collisions, a day and night cycle, local saving, and complete block interaction. On paper, it sounded even better than DeepSeek. Visually, MiMo's version was impressive. It had varied terrain, trees, water, a proper title screen, and a convincing day and night cycle. The chunk loading also appeared to work. There was only one small problem. I could not place blocks, and I could not break blocks, which is a slightly inconvenient limitation for a Minecraft clone. I tried different blocks, different positions, both mouse buttons, and every reasonable interpretation of the controls. Nothing happened. MiMo had created a nicer looking world, but it had failed one of the central mechanics explicitly required by the prompt. For round 2, I made the challenge significantly harder. Both models now had to create a Counter-Strike style first-person shooter. The specification required multiple weapons, localized damage, recoil, ammunition, bots, teams, rounds, an economy, a buy menu, a scoreboard, and a tactical map. In other words, far too many interconnected systems for a model to quietly ignore. DeepSeek received according to the agent, it had implemented physics, shadows, 3 weapons, recoil, reloads, headshots, intelligent bots, team elimination, an economy, a buy phase, and a complete round system. It sounded less like a prototype and more like a finished game. Then I opened it. The result looked terrible. The map was a collection of gray blocks on a blue floor. The bots looked like cylinders wearing beige balls as heads, and the entire thing had the visual identity of a physics demonstration from 2007. But beneath the appearance, several systems did work. I could move, jump, switch weapons, fire, reload, open the buy menu, and view the scoreboard. The crosshair expanded while shooting, the ammunition system worked, and the bots were capable of attacking and killing me. The round reset after death, and kills and deaths appeared on the scoreboard. Calling it Counter-Strike would be extremely generous, but calling it a functional first-person shooter prototype was technically defensible. It was ugly, unbalanced, and not particularly enjoyable. Still, there was a game buried somewhere inside it. Then, MiMo received exactly the same specification. It finished in only 20 minutes, more than 10 minutes faster than DeepSeek. And once again, the report sounded excellent. MiMo claimed that its 6 bots could patrol, pursue targets, navigate the map, and attack using pathfinding. That would have been a substantial improvement, had any of it been true. The movement worked, the weapons fired, the HUD existed, and that is approximately where the good news ended. Every enemy stood completely still. They did not patrol, they did not pursue me, they did not take cover, and they did not fire a single shot. I walked through the map eliminating motionless targets until the game displayed round 1. MiMo had built a shooting gallery and submitted it as a tactical combat game. The difference between its completion report and the actual result was enormous. This was the clearest example of the agent declaring victory without verifying its most important systems. For the final round, I changed the type of challenge. Instead of another complicated 3D environment, I asked them to build a Vampire Survivor style game. The graphics could be simple, but the underlying systems still had to be demanding. Hundreds of enemies, automatic weapons, experience gems, random upgrades, increasing waves, object pooling, and optimized collision detection that would not collapse under the number of entities on screen. DeepSeek started first. DeepSeek completed the project in just under 27 minutes. More importantly, it made a sensible architectural decision. Instead of relying on a heavy engine, it built a custom renderer with the HTML Canvas API. It also implemented object pooling and spatial partitioning to reduce allocations and avoid testing every entity against every other entity. This time, the impressive technical report matched the actual game. The player moved correctly. Weapons automatically targeted nearby enemies. Defeated enemies dropped experience. Leveling up paused the game and presented meaningful upgrades. Extra projectiles, regeneration, health upgrades, and a rotating defensive orb all changed the gameplay immediately. As the waves escalated, the screen filled with enemies while the game remained above 120 frames per second. Eventually, the horde surrounded me and ended the run. This was not merely a working prototype, it was genuinely fun. Now, it was turn for MiMo. MiMo now had one final opportunity to recover. I created another empty project, selected the same maximum reasoning configuration, and provided the identical prompt. It took significantly longer, 58 minutes, compared with DeepSeek's 27. But when it finally finished, the extra time was visible. MiMo's version was much more polished than I expected. It had a clean title screen, persistent high scores, readable enemies, floating damage numbers, multiple weapons, and a well-designed upgrade interface. The rotating orb worked. The automatic projectiles worked. Pickup range visibly changed how experienced gems were collected. Cooldown upgrades increased the firing rate. Health regeneration, area damage, and maximum health upgrades all behaved correctly. Most importantly, the game survived its own stress test. More than 100 enemies could chase the player, while projectiles, rotating weapons, area explosions, experience drops, and damage numbers were being processed simultaneously. There were no obvious freezes or major slowdowns. My run lasted 457 seconds. I reached level 15 and eliminated 571 enemies before the horde finally overwhelmed me. Returning to the menu updated the best score, and starting another run correctly reset the entire game. After its disastrous Counter-Strike attempt, MiMo had produced the most polished project of the benchmark. DeepSeek was more than twice as fast and its version performed extremely well, but MiMo delivered the more polished progression system and the more complete presentation. I'm giving the final round to MiMo. That brings the overall score to 2 rounds for DeepSeek and 1 for MiMo. So, what did this benchmark actually prove? DeepSeek V4 Flash was the more consistent model. It won Minecraft because it completed the core mechanics. It won Counter-Strike because, despite the terrible result, its bots could at least move, attack, and participate in a round. And it created an excellent Vampire Survivors clone in less than half the time MiMo needed. MiMo was much less predictable. Its Minecraft world looked good but failed the fundamental interaction. Its Counter-Strike agent confidently described intelligent bots that did absolutely nothing. But in the final 2D challenge, it produced the most polished game of the entire test. The broader pattern seems clear. Both models can be remarkably capable when the project has a focused scope, simple visuals, and systems that can be implemented and tested independently. But once the project requires complex 3D physics, artificial intelligence, combat, animation, and many systems interacting at once, their completion reports become far more reliable than the actual code. In other words, they are excellent at claiming that they built Counter-Strike. Building Counter-Strike is a different problem. The most surprising part is the cost. These projects required enormous prompts, long autonomous sessions, and hundreds of thousands of generated tokens. Yet the usage remained extremely inexpensive compared with premium coding models. I would not trust either one to autonomously build a production application, but for prototypes, experiments, simple games, and disposable first versions, the amount of work they can produce for this price is difficult to ignore. DeepSeek V4 Flash wins the benchmark, 2 games to 1. MiMo created the single most polished result, but DeepSeek was faster, more consistent, and less likely to imagine features that did not exist. Next, I may give both models an even harder challenge. Although after seeing their Counter-Strike clones, that might qualify as cruelty.